It's very easy to travel through time. All you have to do is increase your speed, and you'll travel faster into the future. What I'm talking about here is an effect of Einstein's special theory of relativity known as time dilation, and it's been proven correct many times in experiments and by observation. Anything that's accelerated to a greater speed will age more slowly than something that's stationary relative to it. In the everyday world, this effect isn't noticeable. If you go for a long drive in a car, you don't find on returning home that your family and friends look strangely older, or that your surroundings have suddenly become futuristic. But it's possible using sensitive equipment to measure time dilation on aircraft journeys. In October 1971, physicist Joseph Hafele and astronomer Richard Keating took 4 atomic clocks on board commercial airliners. They flew all the way around the world twice, first eastward, then westward, and then compared the clocks against others that had remained behind at the United States Naval Observatory. When reunited, the 3 sets of clocks were found to disagree with one another, and the differences exactly match the predictions of relativity. Taking the centre of the Earth to be at rest, the clocks that had flown eastward in the direction of Earth's rotation had a greater velocity than the clocks on the surface, and so they experienced a slower passage of time. Moving westward, the clocks on the plane travelled more slowly than the clocks on the surface, so in this case it was the clocks in the lab on Earth that moved more slowly. The time dilation in both cases was only a matter of nanoseconds or billionths of a second, but within the limits of experimental error, the results were consistent with what Einstein's equations predicted. Of course, if you really want to see what the future's like, you're going to have to travel a heck of a lot faster. In fact, you're going to have to move at a significant fraction of the speed of light, which is about 300,000 kilometers per second. Let's assume you can do this, and that you point your superfast spaceship in the direction of Arcturus, a star that lies about 36 light-years away. When you look at Arcturus in the night sky, you're seeing it as it was 36 years ago, because that's how long it takes its light to get here. 36 light-years is a tremendously long way, about 340 trillion kilometers. At the speed of Voyager 2, one of our spacecraft that's moving through interstellar space at the moment, it would take about 720,000 years to reach Arcturus. Your imaginary spaceship can travel much faster than Voyager 2. Let's say you make the journey to Arcturus at 1/10 the speed of light. Clocks back on Earth will record your journey time as 360 years. Clocks on your spaceship, which are moving slower because of time dilation, measure the trip as taking 358.2 years. That's not going to do you much good, because you'll have been long dead. Better go faster. How about half the speed of light? Now, according to Earth-based clocks, you'll get there in 72 years, whereas your shipboard clocks measure the journey time as 62.4 years. At 99% of light speed, the folks back home will age about 36 years during your trip to Arcturus, whereas to you, only just over 5 years will go by. And at 99.9% of the speed of light, you'll be able to get to Arcturus and back in only just over 3 years, while everything and everyone on Earth will have aged 72 years. You'll effectively have leaped 70 years into the future, but arrived back to a much changed world in which even your youngest relatives are now elderly.